So welcome to this week's Swansea Academy of Advanced Computing Tech Chat. Today, Sean has very kindly invited us down to this lovely space, and he's going to tell us about developing augmented reality applications for the HoloLens.
Cool, thanks. So I'm Sean, and this is Tom, and we've been working on this project, the HoloLens. So thanks for coming down here. There's a reason for doing it in this space, which you'll find out towards the end. So what I'm going to talk about today really is what this project is, very briefly, and then talking more about our experiences working with HoloLenses, the kind of APIs that we have to work with, what these things are, and then some of the challenges that we've had. It's mainly going to be a bit of a downer talk, but I figured that you're the right audience to talk about the challenges rather than talking about all the amazing, wonderful things. So why this project? So back in like 2010 or whenever the iPad first came out, there was a. Do you want to go on the chair? Yeah. So the iPads came out and everyone was like, "This is amazing. This is going to be an amazing." We've got loads of chairs. They're just all in there. This is going to revolutionise education, and Apple really pushed to sell this and market it. And very quickly, a lot of schools spent a lot of money on a lot of iPads, and they kind of came across the Jurassic Park problem of they were so preoccupied with whether or not they didn't stop to think whether they should. And some kind of anecdotal evidence, I used to be a teacher, so I have lots of friends who are in charge of IT at schools, and they're always offering me cheap iPads. Because what they found is that iPads aren't actually as useful as they first thought. They're now investing in Chromebooks, because they actually do the things they want. Okay? And so there was this problem of technology being pushed onto a problem rather than do we actually need this thing? And that's kind of the idea behind the HoloLens. So we've been looking at a lot of the research into using virtual reality and augmented reality in education, and I've read 10 reviews over the past 4 years, and they all got to the same conclusion, which is we don't know if this works. So the idea that schools might start spending money on this today is kind of worrying, and we want to really spend time seeing if this is a good thing to spend money on for schools, and that's the aim of this project. So I'm going to talk about what we've experienced trying to make some kind of prototypes on this stuff. So firstly, what is the HoloLens? So this is a HoloLens. It is a self-contained computer and augmented reality head-mounted display. So it's got, you can see up here, a whole bunch of sensors. It's got 4 environment understanding sensors, a mixed reality capture camera, so there's a camera on there as well as the ones that are actually sensing the space around you. It's got 4 microphones which are used for voice control, and it's got a light sensor that changes things like the brightness. It's got a custom holographic processing unit, which they call a HPU, which is doing all the computation from this sensor information and getting that into the various APIs and stuff. It's 2 GB of RAM and 64 GB of storage. It's got the see-through holographic lenses, which you can see over here. They are 2 HD 16:9 displays, and what's quite interesting is that if you tell the display to render black, it doesn't render anything. So you can use that to kind of occlude things when you're developing applications. I'll talk about that a bit later. So it's got 2 speakers, which you can see on the side here. They're surprisingly good, actually, for the fact they're not actually on your ears. And they are, if you don't know much about virtual reality and augmented reality stuff, they have a thing called spatial sound. So they model where your position is in the virtual world, and so something that's next to you sounds like it's next to you. And it works incredibly well, actually. And then finally, it's got Wi-Fi, Bluetooth, and a micro USB port on the back for charging mainly. So one of the key advantages of these things is they're self-contained as a unit. It's an untethered experience. So a big issue with a lot of virtual reality headsets is that they're tethered to a computer or something, and you end up tripping over the wire or doing something else. So I'm going to go through, so that's kind of a basic overview of the technology, and now I'm going to go through what it's like developing on them and what things you have access to when you're making these applications. So in theory, if you know Unity, you know everything. So a lot of this is made in the game engine Unity, or you'll be working in that for developing apps on here. The oversimplified version of how you do this is to install Unity, download the HoloLens tools, and just click Go. In reality, the continuing support for that is a bit sketchy, and like you've done a lot of work on upgrading the tools from older versions of Unity to newer versions of Unity. So you go on my desktop at the moment, and I've got like 4 different versions of Unity currently for various projects because they all work in certain ones, and a lot of our students have had a lot of issues with that kind of thing.
I think a lot of the challenge has been finding that secret sauce between Unity, the Holo toolkit, and begging no one else to touch anything they've done.
Yeah. And then you also have, if you want to use, so when you're developing, you don't necessarily need a device. So you can also use an emulator, but you need to have virtual machines enabled, right? So you need certain,
Hyper-V.
Yeah. The emulator is okay.
Yeah.
It's pretty decent, but there are some, I'll show you some things you can do with the emulator later on. So basically, if you want to develop on these things, you start off by installing Unity, then you find the toolkit, which they have on GitHub, and that's how you get going. And then you have a bunch of prefabs and different things you can use in Unity to get things going. So I'm going to go through and kind of roughly tell you what I know about these tools. So the first is gaze and tracking the user itself. So a lot of developing like virtual reality and augmented reality applications is kind of changing the way you're thinking. So I make games outside of work, and so I've got a good sense of how to do that. But then when you start making stuff for this, there's some things you have to change the way you think. So the main camera you put in the scene, you basically, when you start, you can, there's pretty much a drop-down menu that you can say create camera and make this a HoloLens project. And it will do a bunch of stuff and it will set up the camera originally. So you'll have this camera in your scene, and that camera will always represent the user. And what that means is you can quite easily, as the application is running, keep track of where the user is, what the user can see. What's interesting is that unless you change it, if you position that 000 in your kind of game world, wherever the user is when they enter the application becomes that 000. And that can be, like, think about that. Imagine you're trying to create a space where you want things in the middle of the room or towards the edge of the room, but you don't know, you don't know where you're starting out. So that's when you have to do slightly more confusing things at the end. I'll talk about that in a bit. So this makes, so like I was saying, having that game object that is basically, you can think about it as the HoloLens device, makes tracking the user and what they see really simple. So you can do things like take ray casts, so you can just fire out a ray from wherever the user's looking and project that onto a point in space, and you know that's where you can like put things like UI elements and different things. Something I've taken advantage of is you can also in Unity, any object has this isRendered Boolean against it. So you can check and say if object is rendered, then the user can see it. And there's some interesting things you can actually do with that. We've worked on a prototype looking at maybe training teachers walking around classrooms being able to see different children. So you can just say, well, am I actually being rendered or not? Something to bear in mind is that this has a limited field of view. So roughly, probably, the best way to think about it is if you hold a phone like about here away from your face, that's roughly how much of a screen you'll see, and anything outside of this, the holograms don't appear. That's something that's because this is a development kit, and it's a new technology. Microsoft have reported they have ways of expanding the field of view, but there are probably actually some better like augmented reality headsets coming down the pipeline that will do it probably better than this. The other thing that is limiting, which is quite surprising, is the culling planes of the camera. So if you don't know what that means, in Unity you see this kind of like box here. That is where only objects inside that will be rendered. So when you're wearing this, there's actually a pretty decent distance in front of you where nothing will render. So if I've put something on the wall and I walk up to it, it will disappear because it's outside the culling plane of that camera. So that's not something you necessarily have to think of when you're developing virtual reality applications. Okay, it's not the same kind of thing. So user input, the first thing, the main way you interact with these is with gestures. So the main gestures you've got are bloom. So bloom is you hold your hand out and do this, and that's usually almost like a controller delete. That's like get out of my application or open up the start menu. You have a simple click, which you hold your finger up first and then click down, that does a tap. And there is a way of holding it, so if you tap down, you're holding it, you can drag things. So this is something that, from Microsoft's site, where they're using those hold things to drag. When you're actually doing this in the application itself, the toolkit has a bunch of prefabs that set this stuff up for you, and you can detect the events of these gestures. One thing to bear in mind, the gestures will only work within the field of view of the device. So the device, this is inside-out tracking, so this knows where it is because it's looking outwards. Whereas when you have something like the Vive, you've got sensors around you that know where your controllers are. Whereas here, you need to have the gesture happening within the field of view of those cameras. And if you write your applications well, what you do is you actually give the user some feedback on that. So the way that you would do it with a normal cursor is that when you put your finger in the ready position, you change the cursor to show the user, yes, I can see your finger, and then you tap, and then it recognises that as an input. But that can cause problems, especially when you're using them. That's probably one of the hardest things to get used to, is where is it that my finger's actually being detected. So voice commands, in my experience, are more reliable than the gestures and more intuitive. And super easy to implement. It's literally as simple as writing down what your voice command is and then implementing some kind of event handler to fire off when that happens. So the best thing that works, that if you go on the Microsoft site, they give you some best practices on using voice commands, and usually it's like 2-syllable things work best, they say. But with all of these things, what's quite interesting is that when you have a situation where you have a bunch of people using the HoloLens doesn't know who is giving the command. So if you've got two people next to each other, we've often had a case where someone's done their gesture and it's triggered the HoloLens next to them. Or someone's made a voice command over here and one over there is activated. So that's something to bear in mind if you're thinking about shared experiences, which is something we'll talk about later. So spatial mapping is an important thing to know. So what we're going to start talking about now is how we could, things you have to think about with that coordinate problem that I told you, where wherever I start with this is 0, 0. So as soon as you turn this on, it's going to be scanning whatever space you're in and starting to make a mesh of the space the user is standing in. And you can see that's the kind of mesh you get up at the end, at the side, and it's pretty nasty actually. It's kind of nasty but surprisingly good at the same time, I think. I did mesh generation in a prior job, and so I'm impressed with meshes generally. So the scanning process is something that you can put at the start of your application and say, right, I want you to scan this room, and you can get a percentage measure in the room scanning APIs to say how well it thinks it knows the room, and you can not launch your application until that has got up to a certain point. And again, there's lots of prefabs to help you do that. And then the mesh itself exists in Unity as a game object as anything else. So you can do things like add a physics collider to it, or you can do intersections with that mesh. So you can do things with the gaze, so you can do a raycast from wherever you're looking, and then do an intersection with this mesh and position something on it. And so that's when you end up getting panels appearing on walls and stuff. And then what you can do is you can also occlude things. So here what they've done is this was an application that was they made it snow, and the snow would build up on the floor, and they're basically saying, I want the spatial mesh to block vision. And if you remember I said if you make something black you don't see it, that's basically what they do, is making this kind of thing black. What you can do, which we're going to show you at the end, is the HoloLens stores a lot of previous spaces it's been in, and it can remember where it's been. And you can actually then import that into Unity for testing and debugging. and you can then use those in the emulator. Because probably one of the hardest things when you're developing on this is sat at your desk doing a test in the same space every time. So you can just drag in any space into the emulator and start walking around it and do tests like that, which is very useful. So one of the best, most effective techniques I think with the HoloLens for making it just generally is putting holes in walls or windows in walls is a very good way of doing things. What this is not good at is transforming the whole environment. Okay, so like because you've got that not very nice field of view, it's just not designed for that. You can still kind of see through these holograms. They look more like ghosts than actually like. In fact, that's a relatively realistic image. You can slightly see the background through there. So there's two techniques you can use to get this effect. There's things called spatial anchors, where what you do is when an object's created, you say, right, I want this object to stay in that same place in space, not to follow the user around. And so you can stick something to a wall there, and it's always going to be on that wall. And the other thing is to use the black occlusion to do stuff. So what they've done here is they just created a black box with a window and put an object in there. If you then were to stick that to a wall, and you've turned on spatial occlusion, you then would, like here, wouldn't be rendered on your HoloLens because it's black. So it would look, and it's a pretty effective effect where you can actually kind of like look around the corner and see things. But again, bearing in mind that culling plane that I told you about, if you get too close, it suddenly disappears. So there is a limitation there. So this kind of explains that a bit more. So we can set our coordinate system up. So we start with wherever 0, 0 is, where this is turned on. And you can set objects to move with the user or to be locked into the world. And that world locked stuff is how you end up doing the holes in the wall. So spatial mapping is quite simple, and it does very basic stuff, like it knows where the walls are and you can stick stuff to walls. The next level past that is spatial understanding, and that's where things get interesting and really complicated. So spatial understanding is all about allowing you to place objects procedurally in a space you don't know what it's going to, in a space you don't know yet. And the way it works is first you would have to scan the room. The scanning process takes a lot longer. You can't just like do this as the user is walking around, or you can't have your application running. You need a good understanding of the environment. And you can see the mesh is much nicer than the one that we saw previously. Then you actually write some conditions to look for spaces. So for example, you could say, I want to find a couch. And I know that most couches will be a horizontal surface with another horizontal surface above it, and then offset slightly. And then the solver will run through and find places in your space that are most likely going to be a couch. And then you can do things like you run that at the start. It takes quite a long time, and it's a pretty expensive process. Also, you can do things like for platforms, so like tables, or you can do things like where's the ceiling, and it will detect, it'll understand that the ceiling is up there, and it will understand the floor is the biggest space there. And once you do that, then you literally have a list of these things in an array that you can then go through and say, right, I want to find the biggest flat surface on the floor. I'm going to place my characters there. And so the actual mesh it creates is made up of 8 centimeter voxels. So it meshes it like that. And this is from a game called Fractions or something? Can't remember. Which is it's one of the most effective uses of that side of things. Because what it does, it's like a detective game, is it scans the room, and then it will do things like it knows where the couch is, and you can be sat on the couch and an AI character will walk in the room and sit down on the couch next to you, which is deeply unsettling. And it does things like recognises where there's space on the walls, and it will put things on the walls, and then the idea is you walk around and you investigate things. But I think this is like, I've not started delving into this yet, but this is where the real power is. And even something as simple as like trying to put a model on a table, you need to recognise where is the table before you can do anything. So a few more things. So that something that is nice about these is that you can have shared experiences. So Shared experiences, what that means is that applications can share the same spatial anchors. So when I said that we can lock coordinates to a point in space, what that does is it locks that set of coordinates in for everyone using holograms, so everyone sees it in the same place. That's all it does. You have to build your apps with that specifically in mind. Unfortunately, there's no like OS level thing, which would have maybe been nice to do that. Yeah, you need to, like, from the ground up, be writing your application with this in mind. You can also use this to make the spectator cam, which we've got one of, but you need to sacrifice a HoloLens. So you have to take one of these apart, 3D print a piece, and then connect it to an SLR camera, and then it actually uses the camera then to see what's going on. So like, go on.
Just you also need then like a capture card system in the back of the PC to run 2 inputs and then make a composite image that outputs onto it. So.
Yeah. So it's like doubly tricky because then you have to rewrite every application for this as well.
And there's a whole calibration setup. You have to stand there with checkerboards doing this for 20 minutes, and every time you move it, it's not as easy as it could be.
No. And so the shared experience, though, I think, this is where the most potential for these are, is with the shared experience stuff. So these are 2 examples, these are Microsoft examples, so who knows if they're, like, how doable they are. But, so the first one is, it's just Skype. So you can, what's quite nice, so you had a bunch of kids in, and they all just started watching Fortnite videos.
Open YouTube, Fortnite.
Yeah. This is what this is. So like, you can have someone helping to fix your plug on a screen there, or whatever. You can do that on the phone, but so this one maybe is a bit more interesting, like having different people, remote colleagues, looking in a 3D space and thinking about something. Okay, and this idea of co-presence. What's quite interesting, like versus, is then how do you represent other people in this space? Like obviously that's a challenge for VR, and like I think even, I don't know, maybe even more weird for this kind of stuff. Especially like in VR, at least you've got a sense of where people's hands are. So in VR you've got the controllers, so you can kind of lock that down and then do some like inverse kinematics to get a decent idea of how I'm standing. But with this, you've just got a floating head, so it's a bit more tricky. So yeah, I mean, I hope that was like at least interesting to see the different things you can do. Key challenges, and then I'm going to show you something on here just to see that you can see exactly what you actually get when you fire these up. Key challenges first is kind of more of a like design challenge, is trying to think when you're making an application in environments you don't know yet. Like how is this going to work if you just give it to someone and they go into a space you don't know? Second challenge is these things run Windows, and that can cause a lot of problems with setting them up to begin with. Like you can pay a lot more to get an enterprise version, which is a lot easier to set up, but like when you were setting up all the 13 that we've got, it took you a while.
Oh yeah.
When you're typing on a keyboard with your head.
I think something else to note is that they're all calibrated to a specific eye set, so everyone sees the world a bit differently. My right eye is stronger than my left eye. They are all calibrated based on that first setup, and the calibration process is not a trivial thing for each individual user. So most people, it's fine using how my eyes see, but we're getting the odd people who are getting motion sickness from an augmented reality headset, which I wasn't expecting. It's not as immersive.
And also, like, I've had to buy new glasses because these are too big. That's a tricky thing. Well, I mean, it's the same with a lot of VR headsets, a lot of these headsets, which, something that surprised me about a lot of HMDs is a lot of them don't have focus wheels. So you have to wear your glasses inside a VR headset, or you have to wear your glasses inside this thing. I mean, it's more obvious with this because you're seeing outside as well, but it's still very, like for glasses users, these devices are still not great. Which is, I think, surprising. Also, like just the general like Windows, like we've had cases where we wanted to run a session with a large group of people, like 10, and like 4 of the headsets randomly want to do a Windows update. So you've got that kind of thing that you wouldn't get with like a headset that's like a dumb, like that's just basically a display. So it's like one of its key advantage of it being all in that one device is also one of its key downfalls. So the limited field of view, but like this is the first iteration, so that will get better. But I don't necessarily think Microsoft will be able to do it, but someone. And tricky interaction compared to like mixed reality or VR. I think that whole gesture problem is we've had problems with that kind of thing. Is that so Microsoft, I don't know if anyone's seen the mixed reality headsets they brought out. You got, which one did you get?
I got Walton Acer. So
Cool.
it's very similar to the Vive. Vive is inside-out tracking rather than outside in.
And then, so the same APIs will work for that. So I don't think it's got gesture recognition, but then you wouldn't want it.
No, you have controller.
Exactly,
They're like Vive controllers. They've got a trackpad and a joystick.
Yeah.
And they've got a trigger and a grip.
Cool. So, and you can do a lot of the actual augmented reality stuff in those mixed reality headsets. So probably that's where, like, if you look at their toolkit, they're very like it's when those headsets came out, they kind of like almost pushed HoloLens like to the side a little bit. And I think, did you say there was some kind of patent issue happening or something weird with the? No, that's not okay.
So just another point on the key challenges as well. The actual form factor of the devices is not the best. They're heavy and uncomfortable after a prolonged 10 minutes, and you really start to feel the front weight on your nose bridge.
Yeah, and I was surprised actually how they do work with young kids.
They do, yeah.
I was not expecting that.
We've had kids doing combat rolls across the floor and they didn't fall off, which I was surprised at.
Yeah.
I'm very nervous about.
Yeah. Do you want to chuck the thing on, or should we go there?
Which one?
Just go on just the kind of development window.
Yep.
So how much do they cost?
$3,000?
Something like that.
Something like that, and the enterprise version is a lot more. So Microsoft, so with VR, so Oculus, they went the route of make their developer kit cheap and get lots of people creating cool stuff. Microsoft went the other way of making their development kit expensive because they only want people who are serious. But I wonder if that backfired on them.
And the mixed reality stuff's only 300, I think.
Yeah, the mixed reality stuff is
What's the
much
difference?
cheaper. So the mixed reality it's a normal VR headset with a screen.
Right.
And then, so you're closed off. So you close it down, you're closed off, but there's two cameras.
Right.
So you can see outside.
Got you.
And
You can't. It sees outside, but there's no pass through as far. Well,
It's just for the sensing.
It's for sensing.
So external sensors.
There's at this point there is no way to get access to that camera
even on
information. You can't
I assume it's
even
infrared, that's what I thought it was.
you can't. I don't know, but you can't even do Vive like Tron mode. You know that you get where on the Vive. So, but it's really useful for running. It's cheap. It's a cheap headset and it works really quickly compared to setup for a Vive or an Oculus.
I'm sure I was watching something on a Lenovo one yesterday that said something to do with being able to do that.
I don't know.
I could
We
be
have the
wrong.
Acer one. The Acer one doesn't have it. You have the Dell one, don't you?
Dell,
Yeah.
It's doing that.
It's kind of bad that it doesn't do that. This isn't on, sorry.
No, it's not on. I have to refresh.
Sure.
What version of Windows are they running? Is it embedded or?
It's a full version of Windows,
full Windows 10, is it?
but it's an adapted version, I think.
Right. Okay.
Because of the limited things, there's no mouse, there's no keyboard.
Yeah. So presumably it's using all the DirectX stuff that ships with that. Is that what it's using? That base or?
I don't know.
Yeah. Okay.
So there's a controller involved which comes with it. Is that particularly useful? Is it hard to implement that or?
No, so what the control, so it comes with this.
Yeah, it has.
So it comes with one of these.
Yeah.
This replaces this.
Yeah.
That's all it does. And to be honest, I prefer using it, apart from the fact that batteries on these go like unbelievably quick. Like really.
So the headset, I think, will run comfortably for 2, maybe 3 hours. The little controllers, I think, half an hour.
Yeah, they do. So there's no so you don't have to do any more additional setup. It's just the
No,
same.
no,
It's the same.
Yeah,
it's the
yeah,
same
yeah.
controls for them.
Do I need to put this on?
I
I was trying to having a bit of trouble with
Especially if it's a working electrical, they don't like glass.
I was going to say yeah.
It kind of it's been okay with this.
Right, so we're on.
Right. So if you go to the 3D view, or you actually go to the mixed reality capture first. I'll actually put it on.
What's your delay? Mine's about 30 seconds over there, Jerome. Do you guys have your own network? Do you?
We're on a.
We have our own network in here, yeah.
Yeah. So what's your delay?
About 2. It depends which way we're running it. So we can run it through VLC live stream as a network stream,
Yeah.
which I think is a bit more stable than. But that then leads to a 2-second delay.
Yeah.
Ish.
I have a 30-second delay on the ones I'm using, and it's a pain in the ass.
Yeah.
Long delay, isn't it? Yeah.
That's why I'd be much more interested in trying to get some of these spectator cam
Yeah.
arrangements set up. It's a much more direct way of doing it. And I also worry that the live, our heads are really, really good for compensating for the little movements we make of our head on a 40-inch display. That's quite jarring, seeing someone else's head movements.
You mentioned smoothing, which would normally happen. But
Yeah.
Mhm.
Do you want me to go to the live preview?
Yeah. So this is quite useful for like capturing, like just capturing videos of stuff you've made. We've used it before, but then yeah, just seeing what I'm doing. I mean, I can play some holograms.
Get the Cortana look.
Yeah.
Don't say it too loud.
Yeah. Let's go.
So the delay, you've got a 30-second digital delay. Is that what you
Yeah. So if I raise my hand, you'll see it will take a while before my hand comes up. Which is it's quite frustrating when you're trying to explain to someone what they're doing and they did that action like 10 seconds ago, so you're trying to wait to
And that's another key challenge, is that you can't. So at least with virtual reality, you can see the screen and help them.
Yeah,
You can see what they're seeing, but here,
Yeah.
this is the only way to do it.
Yeah, visual screen, what's it called? Display viewer is pretty useful.
Yeah.
Is the USB any better, by the way? Because I've never imagined the USB to work. I didn't take time to.
We haven't had much time either.
Yeah.
Do you want to do the 3D view? Do you want me to go there?
What do you want me to do?
The 3D view. So show the if you click on 3D view.
Yeah.
Yeah.
Seasick, can't you? Just watch
Okay.
it.
Isn't it upset at the moment because it hasn't got a space?
Yeah, but it'll try. Hopefully, click the update on spatial mapping. So
Oh.
now you can see it actually mapping the space. If you see, you can left click and mouse wheel to zoom, mouse scroll in. Yeah. So then you can actually see like you guys, which is incredibly creepy. And
Usual audience.
but you can see. So like if this gives us an idea of the camera, like so you can see where I am, and look at the distance from that globe thing to the clipping plane at the front.
Yeah.
So that that's a fair distance. You can definitely notice it when you're
You
using
can
it.
change that in the Holo Toolkit on Unity.
Yeah.
You can make it
Does
quite
it
short.
does it actually
You
work?
can get to about here.
Yeah, and it still works. Okay.
Your eyes start to go a bit. I think that's why you've done it.
Yeah.
That's the convergence problem, isn't it? Because technically it's a 2-meter plane in front of you, so when you get really close, your eyes are like crossed, but the point is actually out in space.
But yeah, what you can do as well. So what's quite if you do start working with these, if you then click save, you can then you download like a prefab. You can just drag into Unity, and then you can do all the stuff in the emulator, which is very useful. But that's kind of it. So you, like this is the most useful thing I didn't know until too late. Is this web page? It's not obvious that I'm not even sure how I found it. I think like it was just that, I wonder if I should type the IP address into like I knew that you could do the recording, because before you can say, hey Katana, take a recording, and then she records and sends it somewhere. But yeah. So any questions, thoughts?
Cool.